Hello, this is the design thinking project titled Rivers and Cities, Energy and Sustainability, being developed with grade 5 at Escola Concept in Ribeirão Preto, Brazil, that began on May 20th and will continue until August 30th. Our project objective is identify the principles of energy generation through rivers and sustainable solutions for the production of hydroelectric energy, minimizing the associated environmental impacts. With this project, we hope that students will develop skills to recognize what increases water flow pressure, produce magnetism through electric current, build an electric engine, understand how an electric generator produces electrical energy, and identify the main sustainability challenges in hydroelectric energy production. By the end of the project, we intend to conduct electromagnetism experiments, homemade electric engine, electrical energy generation circuit, reservoir with water column height sensors. Our guiding question is: how can cities use rivers sustainably for energy production, minimizing their environmental impacts? We began the empathize or understand phase by studying the relationships between rivers and cities. With a circle map, students brainstormed activities and actions that highlighted the interdependence of rivers and cities. In the define, still in understand phase, we chose to develop a project that studied how electricity is produced in hydropower plants and how the construction of this energy model impacts rivers and cities. We began the ideate and prototype or explore phase with a practical study on a school staircase to understand the role of large dams in hydropower plants. Using plastic bottles, hose, connectors, and faucets, we explore how increasing the height of a water column also increases the pressure. Next, we started to understand the effect of electromagnetism on ferrous materials or magnets. To do this, we built electromagnets using batteries, enable copper wires and screws, and we engage in fun electromagnetic challenges among student groups. With this, students were able to understand how an electric engine works, transforming electrical energy into movement. Students then built homemade electric engines using batteries, safety pins, enable copper wires, and magnets. The last stage of explore phase was to understand the relationship between the electric engine and the electric generator. For this, we conduct a practical experiment to light an LED bulb by spinning the rotor of a mini electric engine. In the test or materialize phase, students understand how electricity is produced in a hydropower plant. Then they identified the uses of electrical engines and other forms of energy production. We plan to conclude the project by addressing the sustainability challenges of hydropower plants on cities and the environment, discussing climate change and its impact on rainfall patterns for dams. We will use a water reservoir with Arduino system sensors to simulate the detection of excess water, for example, have rainfall, normal water levels, or low water levels, for example, drought conditions. This information will be sent to the Blink platform. The Blink platform will allow students to monitor the water reservoir volume in real time and reflect on the need to open or close the gates of hydropower plants, whether the weather is wet or dry, whether electricity tariffs should rise or fall, or whether cities should take measures to ration the use of their rivers' waters.